Section 3.2.4, we're going to find solutions to this quadratic equation using the calculator table function. I've not done it before, but this is how you do it. First thing I'm going to do is I'm going to rewrite this as the way we're going to use this. I'm going to rewrite it as y equal to x squared minus 2x minus 5. Then I'm going to put it in the calculator. I'm going to put it in just like we're graphing it. Turn the calculator on, go to the graph. Same thing we always been doing, and I'm going to graph it as x squared minus 2x minus 5. Do I have it in there right? I do. So now what we're going to do is rather than go to the graph, we're going to hit the second button, and that will take us to the table. The second button, second table, puts this thing in a table for us. So now we have a table of values. It started at x equals 0, so y is equal to negative 5. When x is 1, f of x or y is equal to negative 6. When y is 2, or when x is 2, y or f of x is equal to negative 5. We need to find the values when y1 is 0. When y1 is 0, we want the value of x. That's what solves this equation. So I need to do that. What I'm going to go do is cheat and go look at the graph. The graph tells me it's between negative 1 and negative 2. So I'm going to go back to the table. And I don't know why they separate these buttons, but the table set is over here underneath Windows. So I'm going to change the table and tell it where I want it to look for this 0. So I'm going to hit second, table set, and I'm going to tell it I want it to start at negative 2 because that's where I saw my 0. And now I'm going to leave it the way it is and do the table and see what it has. Second table. So now it starts where I want it. It starts at negative 2, and you see that y is positive, and then at negative 1, y is negative. We saw earlier that that means that there's a 0 between these two. So what I'm going to do is 0 between these two. So now I'm going to use this table feature to get even closer to what that 0 is. I'm going to go back to table set. I'm going to tell it I want it to start at negative 2, but now I'm going to tell it the difference between each x value I want to be 0.1. That's what that delta table means. I don't know why they call it table. They should just call it delta x. But the difference between each x in the table is 1. Take a look at this. The difference between the table on each x is 1. So now in the table set, I'm going to change that to 0.1. So now the difference between x is 0.1. It's going to start at negative 2.1. Then it's going to go to 1.9 and then 1.8 because the difference between those is 0.1. So now go hit the table. So as you can see, the difference is now 0.1. I go to negative 2, negative 1.9, negative 1.8, and I see that the sign changes now between 0.25 and 0.24, or is between negative 1.5 and negative 1.4. So that negative 1.5 is going to be my new x start. So I'm going to go here to second table set, make that negative 1.5, and now I'm going to make the difference between each x value 0.01. That's 1/100th. 0.01, and I'm going to do it again. And when I do that, my table says that I have my, what's not right here? 0, 0, 0, 1.6. Oh, negative. It needed to be negative. Go back and hit table and make it negative. I overwrote it. Negative 1.5. Do the table. I don't want to graph it. I want to do the table. Second table. There we go. Negative 1.5. Where's the sign switch in here? The sign switch is right here between 1.45 and negative 1.44. That's where the sign change is. So now I'm going to put negative 1.45 in the table set. Negative 1.45 in the table set. I'm going to make my difference between my x values as 0.01, that's 1/1000th, and do the table set one more time. Do the table. And now between negative 1.45 and negative 1.49 is where the sign change is. So I'm going to write this, and it's all the way down. My answer to this one, based on this to the nearest thousandth, is going to be 1.449, negative 1.449. That's one of my x's. I'm going to write x equal to, come on, x equal to negative 1.449. So that's one of my x's. I found one of them. I got to find the other x now. So I'm going to go back to my graph. The other x is between 3 and 4. So now I'm going to go back and find it with that one, setting my first x as 3. And I want to go back here and change my table set, change my delta x, my difference between the x's, as 1. No, I can actually set it as 0.01. Stop. I can set it as 0.01. 0.01. And hit the table. Take a look at the table. Second table. And the sign changed at -2. The sign doesn't change before it gets to 0.31. I should have left it at 3. No, I shouldn't have left it at 3. That's 0.01. I wanted 0.1. I didn't do the table set. I didn't do the delta x right here. I didn't want 0.1. I want 0.1. Second table. Second table, there's my sign change right there between 3.4 and 3.45. So now 3.4 is going to become my x begin, and 0.01 is going to become my delta x. So what did I say? I think 3.4. 3.4. We're going to find out. Arrow down to 0.01. Enter 0.01, take a look at the table. And between 3.44, I'm going to guess it's probably going to be 3.44. It is. 3.46, there's my sign change right there. So it's between x equal 3.44 and 3.45. So now the 3.44 is going to become my x begin. .44 is going to become my x begin. I'm going to arrow down to -0.001 and hit enter. And oh, I'm not going to hit enter. I'm going to look at the table. Look at the table. And it changes at 3.449. That's what I'm going to put. I'm going to put -3.449. I don't know exactly what it is. What I want you to notice is these are not exact answers by any means. The calculator has ways of being much more accurate than what this method is. I'm not really sure why the book has decided that you need to do it this way, but I'm going to show you because there's a lot of calculator stuff in here that you guys don't like a lot. 3.449. So these are the x values. If I had to answer this one on the test using these methods, these would be the x values that I would turn in as the solutions to this equation up here. When I put x in for x, when I put this in for x in this equation, I put this in for x in this equation. This is going to be really, really close to 0. I don't know exactly how close, but it's going to be really, really close to 0.